Students, I come up with another video from Thermodynamics. I hope you have watched all my previous videos from the Thermodynamics. Here, let us discuss everything about heat and heat capacity. And I will give you previous questions and short tricks to solve those questions. Okay, let us first clarify what is these two ideas. If I ask students in my classroom, what is Q? If I ask any students, 99.99 students they answer me Q is equal to heat. Q is equal to heat. Is it right? Is Q means heat in thermodynamics? Never. What is Q? Then I will correct them. It's not heat, but it is amount of heat energy released or absorbed by any system. Look at the completeness of the definition. Q is the amount of heat released or absorbed. Therefore, there are two directions, that is plus and minus. Plus means heat absorbed, amount of heat absorbed. This is heat released. Okay. Fine. Now, does any relation between Q delta H and delta E? Any relation? Of course. QV is delta E. Plus or minus QV is the plus or minus delta E. Plus or minus QP is equal to plus or minus delta H. What is this? Delta E is the enthalpy change, nothing but heat released or absorbed by a system at constant volume. Okay. QP, it is nothing but delta H, that is enthalpy change is heat released or absorbed by a system at constant pressure. Therefore, you have a very beautiful relation like QP is equal to QV plus delta NGRT. This relation is equivalent to delta H is equal to delta E plus delta NGRT. Okay. Therefore, students, my request is, wherever you see Q, never say it is heat, but it is amount of heat released or absorbed. Now, we can go to another idea. What is heat capacity? Heat capacity. See, you know, Q directly proportional to delta T. What is this relation tells you? You have a system, any system, if Q released, delta T decrease, change in temperature temperature decreases. If Q is a system, if you give Q to the system, temperature of the system will increase. Therefore, temperature change depends upon heat absorbed or released, magnitude, amount of heat absorbed or released. More heat absorbed, more temperature increased. More heat released, more temperature decreased. Okay. Therefore, Q is equal to a proportionality constant of C delta T, where C is heat capacity. What is C? Q by delta T. Very simple. What is the definition of C? What is the definition of C? Suppose delta T is 1 degree centigrade. 1 degree centigrade. Delta T is 1 degree centigrade. Therefore, Q becomes C. What is Q? Amount of heat released or absorbed by a system to make its temperature change 1 degree centigrade. Q is nothing but, heat capacity is nothing but amount of heat released or absorbed by a system to make its temperature 1 degree centigrade, to decrease 1 degree centigrade or increase 1 degree centigrade. Okay. Therefore, Q is equal to C when temperature change become 1 degree centigrade. Okay. Now, students, we have different kinds of heat capacities. We have heat capacity, different kind. One is specific heat capacity. Second one is molar heat capacity. Third is heat capacity at constant volume. The fourth, let me write here, heat capacity at constant pressure. This is represented by CS, this is CM, this is CV, this is CP. This CM again CSV or CMV. This is again heat capacity at constant, specific heat capacity at constant pressure or molar heat capacity at constant pressure or CPM. Okay. This should be very clear. What is this? Specific heat capacity. What is heat capacity? Amount of, remember, Q is equal to C, where delta T is equal to 1 degree centigrade. What is Q? Amount of heat absorbed by the system to rise its temperature 1 degree centigrade. Specific heat capacity, nothing but mass of the system. Mass of the system is 1 gram. Here, mass of system is equal to its molar mass. Mass of the system is equal to molar mass. This is 1 gram, this is molar mass. Specific heat capacity of water, remember, 1 calorie per gram in calorie or 4.184 joule per gram. Remember this, please. It is required for the calculation. If the calorie specific heat capacity of water is 1. If it is joule, 4.18. Therefore, specific heat capacity is the heat capacity of the system when its mass is 1 gram. Very simply talking, amount of heat required to rise amount of heat required 1 gram of a substance to rise its temperature 1 degree centigrade. Here mass of the system, mass of the substance should be molar mass. What is heat capacity at constant volume? Nothing but you measure the heat capacity. System is kept at constant volume. Here system is kept at constant pressure. Therefore specific heat capacity can be at constant pressure, or molar heat capacity can be also at a constant pressure. Now, calculation of Q, that is very important. Calculation of Q. How do you calculate the Q? Calculation of Q or CS, heat capacity, specific heat capacity. If you get the specific heat capacity, Cm is nothing but the Cs into molar mass. Molar mass. That is, because it is for 1 gram, therefore Cm for molar mass gram. Calculation of Q and Cs. Remember this equation. Q is equal to M into Cs into delta T. This is amount of heat released or absorbed. This is M is equal to mass of substance. Cs is equal to specific heat capacity of substance. Delta T is equal to temperature change of substance or system. Q is equal to, here amount of heat released or absorbed depends upon if it is released minus, if it is absorbed plus. The same equation, if it is at constant pressure, that is delta H, is equal to M into Cs delta at constant pressure delta T. QV is equal to delta E or delta U is equal to M into Cs at constant volume into delta T. Very simple. The Q can be QP, therefore specific heat capacity should be at constant pressure. The Q can be QV or delta E when specific heat capacity at constant volume. Now there is another very important equation that has been used in various examinations. That is we know that Q is equal to C delta T, or QP is equal to CP delta T. CP is heat capacity, neither specific nor molar, general heat capacity. Okay? Or it is delta H is equal to Cp delta T. Now again, suppose d delta H by dt is equal to Cp delta T by dt by dt. D delta T by dt, that is 1. Therefore, this is very important. Delta change in d delta H, d delta change in enthalpy with respect to temperature is nothing but delta Cp. That is delta Cp. Here also delta Cp. Very important. d delta H by dt is equal to delta Cp. Changing heat capacity. Therefore, changing heat capacity is nothing but change in enthalpy change with respect to temperature. Okay? Yes. Therefore, I summarize the equation. Please remember this equation. Q is equal to M Cs delta T. Change in heat capacity is equal to d delta H by dt. Okay. Now we can solve some questions. Previous questions. Look at this beautiful question. Previous question, jam question. A 45 gram, let me check the video. Okay. A 45 gram sample of an alloy was heated to 90 degrees centigrade and dropped into beaker containing 82 gram water at 23.5 degrees centigrade. The temperature of the water rise to a final 26.25 degrees centigrade. What is CS of alloy? Look at the question. 45 gram sample of an alloy was heated. You have a 45 gram sample alloy. You are heating that, and its temperature become 90 degrees centigrade. Then you drop this alloy into a beaker containing water. Because of that hot alloy, water temperature increased, and that raised from 23 to 26.25. What is the specific heat capacity of alloy? You know the specific heat capacity of water in calorie, or 4.184 in joule, or 1 calorie per gram. Okay. We want to know the specific. We have an equation Q is equal to Cs mCs delta T. You want to calculate, this is for alloy. If you want to calculate this for alloy, you should know delta T m. You know the m, but you don't know what is delta T. Only final temperature has been given. Okay? And you don't know what is Q. But in the case of water, if you take the water mass is 82 degree. CS has been given. Delta T also given. What is the delta T? 26.25 minus 23.5. Okay. That is 2.75 degree centigrade. 2.75 degree centigrade. Therefore, the water heat has been raised. The water heat has been raised because it absorbed heat from the alloy. Therefore, you can calculate how much heat absorbed by the water. That is 82. I am going to calculate in calorie. Therefore, 1 calorie per gram into 2.75. This much heat absorbed by water because temperature increased. This value is 2 to 5.5 calorie. This is the heat absorbed by the water. Obviously, this is the heat released by metal. Therefore, you got the heat released by the metal. What is that? 2 to 5.5 heat released by the metal. Okay. What is the gram mass of that metal? It's 45 into CS into CS. Now what is the temperature? Delta T. When you put the alloy in the water, its temperature was 90 degree. Okay. How much the temperature become changed? The final temperature of water is 26.25 degrees centigrade. Therefore, water alloy system will have almost 26.25 degrees centigrade. Am I correct? Therefore, the temperature change is this. Because it is 90 degree. When I put this into cold water and temperature of that water become 10 degree or 20 degree. Now the water and alloy together, that system has 20 degree. Therefore, here the temperature change is almost this value. Therefore, our equation CS into, here no need of negative sign. Okay, negative sign, no problem. Here you will have a negative sign. This will also give the negative sign. Both will calculate. That is 26.25 minus 90 degree. There will be a minus and minus cancelled. Finally, the CS will be 225.5 all divided by 45 into 90 by 26.5. Okay, when it comes minus, don't forget minus and minus cancel. Okay, no problem. This is specific heat capacity of that metal. Very simple question. I think the idea is clear. Now we can go to next question. Another previous question. IIT question. Very simple question. When 20 gram aluminium is heated from 90 degrees centigrade to 115 degrees centigrade calorie, 105 calorie is required. This much heat is required. What is CP? What is CP? What is its CP value? Heat capacity, specific heat capacity. That's the question. Simple, very simple. Q is equal to M CP. Therefore, here QP delta T. Why I write CP, specific heat capacity at constant pressure. Therefore, I write the QP. 105 calorie heat is required. Therefore, QP is 105. M is given 20 into CPS. Temperature change is, what is the temperature change? 25. Therefore, its specific heat capacity is equal to 105 divided by 20 into 25. This is for 1 gram. If you want its molar heat capacity at constant pressure, get this value. This value, that is specific heat capacity. Then multiply with 27. You will get the molar heat capacity. Okay. If you want molar heat capacity, you do multiply with 27. This is specific heat capacity. This will give you specific heat capacity. That is heat capacity of that 1 gram of aluminum. Remember, heat capacity of 1 gram of aluminum. Now we can go to another question. Previous question. Okay. At a very low temperature, the heat capacity of solid is proportional to T cube, and we can write CP is equal to alpha T cube, where alpha is equal to 3 into 10 raised to minus 8 joule, Kelvin raised to minus 1, mole raised to minus 1. What is change in enthalpy delta H when it is heated from 0 Kelvin to 300 Kelvin. Okay? Yes. At very low temperature, heat capacity of solid is proportional to this. And Cp, a relation for Cp has been given, where value of alpha is given. What is delta H? When it is heated from heat capacity of solid given. This is a heat capacity of solid. Heat capacity alpha T cube, T is the temperature. Value of alpha is given. Now what is delta H when it is heated from 0 Kelvin to 300 Kelvin? Delta H and heat capacity change with temperature. Delta H is equal to Cp delta T. Okay? Or Qp is equal to Cp delta T. Where is general heat capacity, not specific heat capacity, general heat capacity. This is equivalent to this equation. Q is mCs delta T. This mCs together is called Cp, heat capacity of that substance. Okay. Cp when it is Qp. Okay. Now delta H is equal to what is Cp? Alpha T cube delta T. Now what is the delta H when it is heated from? What is the delta H when it is heated? This is our relation. What is the delta H when it is heated from? Delta H when it is heated from 0 to 300 Kelvin, which is equal to alpha is a constant, T cube dt 0 to 300. Okay? Delta T, for integration I make dt. Okay? Now, integral d delta H or d delta H, that is delta H, is equal to alpha. What is integration? T4 0 to 300. That is delta H is equal to alpha into, by 4, alpha by 4 into T4 when after applying the limit. Okay? Now you know that what is the value of alpha? Value of alpha has been given. Therefore delta H is equal to 3 into 10 raised to minus 8 T 300, because limit has given, this is for 300 raised to 4 all divided by 4. This is delta H. Okay? I hope this numerical is clear for you. Keep on watching. Subscribe the channel. I will upload next videos from the thermodynamics. Okay, let us together qualify the competitive examination. Thank you.